Welcome all to Kinematics class 8, in which we'll discuss about the analysis of graph by using the concept of area under the curve. First we'll discuss the basic concept related to this. Suppose if you're having a graph between the coordinate y and x, and let's say if you're getting the shape of graph is something like this. So in basic mathematics we already discussed how to find out the value of area under this curve. So if Rm is to find out the value of area under this curve with respect to x-axis, so the equation for this area is nothing but integration of y dx, and within the specified limit, so we'll be able to find out what about the value of area under this curve. So in this graphical representation of motion also we'll use this concept. So from our the equation for velocity, that is velocity is equal to ds divided by dt, that is a rate of change of displacement. Normally we'll use this equation when velocity is not a constant or to find out the value of instantaneous velocity. Now we can write from this equation ds is equal to nothing but v dt, or if you are integrating on both the sides we'll get the value of displacement, that is equal to integration of v dt within this specified time limit, let's say from t1 to t2. If you are specifying the same thing in a velocity time graph, so if you are having a velocity time graph and the graph is something like this, so if you are finding out the area under the curve, so from the previous equation we can say that this area under the curve will be equal to integration of v dt, and integration of v dt will give the value of displacement. So we'll use this concept that area under velocity time graph will give the value of displacement. Area under velocity time graph will give the value of displacement. Now from the equation of acceleration, that is a is equal to dv divided by dt, we can write this dv is equal to nothing but a dt, that means integration of dv will be equal to integration of a dt. Let's say the value of velocity is changing from u to v, and when time is changing from, let's say, t1 to t2. So the integration of dv can be written as nothing but v, and the limit is changing from u to v is equal to integration of a dt from time t1 to t2. So if you are putting the limit, we'll get the value as v minus u, which is nothing but change in velocity, is equal to integration of a dt. So from this concept we can say that if we are having a curve between this area between acceleration and time, and if we are calculating what about the value of area under this acceleration time graph, so according to the equation we can say that this area will be equal to integration of a dt, and integration of a dt will give the value of v minus u, which is the value of change in velocity. So we can write area under acceleration time graph will give the value of change in velocity. Just remember that area under acceleration time graph is not going to give the value of velocity, it is going to give the value of change in velocity. Now from the equation of acceleration, that is a is equal to nothing but dv divided by dt. The same equation can be written in this form if you are multiplying with ds and divided by ds. Here the term ds divided by dt is nothing but rate of change of displacement, which is nothing but giving the value of velocity. So we can rearrange this equation as nothing but v dv divided by ds. So we can write it like this: the value of v dv is equal to nothing but a ds. Now if I'm integrating on both the sides, let's say the value of velocity is changing from initial velocity u to a final velocity v, and this displacement from, let's say, value s1 to s2. So if you are integrating this, integration of v dv can be written as nothing but v square divided by 2, and the limit is changing from u to v will be equal to integration of a ds within its specified limit, let's say it is from s1 to s2. So if I am putting the limit, we'll get as it is v square minus u square divided by 2 will be equal to nothing but integration of a ds. So we can say that if you are having an acceleration displacement graph, then area under this acceleration displacement graph is going to give the value of this area. We can written as nothing but integration of a ds, which is going to give the value of v square minus u square divided by 2. So over here you can write area under acceleration displacement graph will give the value of v square minus u square divided by 2. So if there is a question related to this area under the curve, so either they will give a velocity time graph, or they will give an acceleration time graph, or they will give an acceleration displacement graph. So area under velocity time graph will give the value of displacement, area under acceleration time graph will give the value of change in velocity, and area under acceleration displacement graph will give the value of v square minus u square divided by 2. Hope so that you understood whatever we discussed in this class. If you are having any doubt, please ask. Thank you.